In today's class, we are going to learn motion. Let's start by taking the definition of motion. Motion refers to a change in position of a body with respect to time. Now look at this. This is where I'm standing before. If I change my position to this place, that is, I move from here to here, that means my position has changed. In that case, the position does not only change, it changes with respect to time. That is, time is factored as during the change in position. That is what is meant by motion. So when the position of a body changes with respect to time. Now, let's look at the equation of uniformly accelerated motion. Equation of uniformly accelerated motion. Okay, there are three major equations of uniformly accelerated motion. So the first one is V is equals to U plus AT. The second is V squared is equals to U squared plus 2AS. The third is S is equals to UT plus 1 over 2 AT squared. These are the three major equations of uniformly accelerated motion. But we have another one, which is S is equals to V plus U over 2 multiplied by time. But these are the three major ones. You understand? Let me put it major. These are the three major equations of uniformly accelerated motion. Now, let's take down the parameter that we have in the formula. You can see we have V. V is V means velocity, final velocity. You understand? If you followed our class on the basic concept of physics, you realize that we have talked about velocity, acceleration, time, displacement, distance, and how they are related. So V means velocity. U is and V means final velocity. You understand? U is also velocity, but U stands for initial velocity. You understand? A means acceleration. A is acceleration. T is time. You understand? And S is what? Distance or displacement. You understand? S is distance or displacement. But majorly, mostly in physics, we only make reference to distance. You understand? So, and also distance. S means distance. But also, we can also refer S as displacement when we are talking about velocity. But most of the time, we make use of distance as, S as distance. You understand? And also, the unit of velocity, which is V, is meter per second. Please, it's very important that you note that velocity is meter per second. U, which is initial velocity, is also what? Meter per second. Is there any other parameters? Okay, we have A. Acceleration is meter per second squared. Also, we have T. T stands for time, and time is what? Time is in seconds. You understand? Seconds. And we also have S, which is distance. S is what? In meter. Do you understand? When we talk about time in physics, there are two T. We have capital T. T for the small letter T is what? Is for seconds. So you don't use capital letter. Capital letter stands for period. You understand? So T is what? For seconds, which is small letter T. Now we have taken the parameters that we have in this equation. Before we move to to questions, it's very, very important that we understand the basic concept. Okay, you understand? So now I want to note this. If a body begins from rest, that is, if a body starts from rest, the initial velocity of that body is 0. Initial velocity is U, and U is what? 0. For a body that begins from rest. Okay? Now, if a body comes to rest, maybe the body has undergoes motion before, then the body is coming to rest, the final velocity V will be what? 0. Please, it is very, very important that you note this case. Okay? If a body begins from rest, you understand? That is, the body is not in motion before. If the body starts from rest, the initial velocity of that body is 0. You understand? But if a body is on motion before, then it comes to rest, then the final velocity is what? 0. Do you understand? So now let's talk about the concept of retardation. Let's say we have a body moving at a constant velocity. In that case, the body will cover equal space at equal time interval. Is that not it? Because the body is moving at a constant velocity. Now, if the body wants to increase its acceleration, the body has to increase its velocity. You understand? Because acceleration tells us how the velocity of an object is changing with respect to time. Now, if that same body wants to come to rest, what will happen to the velocity? It will have to reduce the velocity, Abi. That is what we call retardation. Retardation simply means negative acceleration. You understand? The type of acceleration that brings a body that is in motion to rest is what we call retardation. You understand? So the relationship between acceleration and retardation is that retardation is simply negative acceleration. You understand? Another term that is used to describe retardation is deceleration. You understand? Another term that is used in describing retardation is deceleration. It's very, very important that you note that. Now, I want to write this down. Retardation refers to negative acceleration. It is a kind of acceleration that brings a motion of a body to rest. You understand? It is a type of acceleration that brings the motion of an object to rest. Let's say you are driving a car and a boy suddenly ran across the road. What will happen? You will actually press the brake, Abi. Now, when you press the brake, what happens to the acceleration of that car? The acceleration of the car reduces. That is what is called retardation. You understand? Retardation simply means negative acceleration. The kind of acceleration that brings the motion of an object to rest. So for this, if we have, this is retardation. Retardation simply means retardation is equals to what? Negative acceleration. Do you understand? So you are going to see how we apply all these basic concepts in physics by the time we start solving question. Okay, now let's talk about free fall. What do we mean by fall in physics? Fall simply means the vertical and downward movement of a body. That is what we mean by fall in physics. You understand? So when we talk about free fall, when an object undergoes vertical or downward motion under the influence of gravity, that is what we call free fall. Do you understand? So, look at this marker. If I throw this marker up, it's going to come down. Why? The marker is moving under the influence of gravity. You understand? So that's a typical example of free fall. That is the vertical or downward movement of a body under the influence of gravity. Now, in free fall, the acceleration is equals to acceleration due to gravity. The acceleration due to gravity is represented like a using a symbol that looks like G. You understand? In physics, we represent like a as G, acceleration due to gravity. Let me just run this. Acceleration due to gravity. That is G. Do you understand? So under free fall, we represent the acceleration as acceleration due to gravity. Represent the acceleration under free fall as acceleration due to gravity is because for every object that goes up and comes down is acted upon by the force of gravity, because gravity is the force that causes an object to come down. You understand? So A is represented as acceleration due to gravity. And another concept that changes is S, the distance. In acceleration due to gravity, S is represented as h. S is represented as h. Don't forget that in our equation of uniformly acceleration motion, S is represented as what? Distance. But when we talk about in acceleration due to gravity, we are not taking S as horizontal distance. We are taking X as what? Vertical height, vertical distance. That is height. You understand? So you know, uniformly acceleration motion, in uniformly acceleration motion, s is measured horizontally, you understand, but in free fall the distance is measured vertically. For example, if I throw this marker up like this, the marker comes down, I cannot say that how distance, you understand, I can only say how high does the marker goes, you understand. So for free fall, we represent s, which serves as distance in uniformly acceleration motion, as height. Do you understand? So those are the two parameters that changes for the equation of free fall, you understand. So if I plug in both g and h, let me represent it as height h. So if I plug in both g and h into this equation of uniformly acceleration motion, what am I going to have? I'm going to have v, let me call this free fall. I'm going to have, for the first one, I'm going to have v is equals to what? U plus gt. Do you understand? That is, I've replaced a with g, which is acceleration due to gravity, because we are dealing with free fall. Do you understand? So v is equals to u plus gt. Then the second equation becomes v squared is equals to u squared plus 2gh. You understand? I have replaced s as h and g as what? And acceleration as what? Acceleration due to gravity. And the third equation becomes s is equals to h is equals to ut plus 1 over 2 gt squared. Do you understand? So these are the equation of free fall, motion of an object under free fall. Now this is the first version of equation of a body falling under the influence of gravity, that is moving under the influence of gravity. Now another version is this: v is equals to u minus gt, v squared is equals to u squared minus 2gh. Then we have h is equals to ut minus 1 over 2 gt squared. Okay, now let us proceed. The reason why we have two versions of this equation is because, look at this. Immediately I throw this marker up, what happens to the marker? It comes down. Why does the marker come down? The reason is because the force of gravity acts upon the marker. Are you getting it? Immediately the marker goes up, what happens to it? It comes down. When the marker is going up, the marker is acting against the force of gravity. You understand? So when the body is moving vertically upward, the body is acting against force of gravity. In that case, we are going to make use of this formula. That is, the value of g is negative. Do you understand? Please, it is very, very important that you pay attention. This is the basic concept that you have to understand. Now, when we are given a question and we are told that the body is moving downward, we are going to make use of this formula. We are going to make use of this formula. The value of g will be positive. Do you understand? So that is why we have two versions of this equation. You understand? For example, when maybe we are given a question and said, calculate the distance of an object that falls so. The object is falling, so it is moving towards gravity. So we are going to make use of this equation. But in an instance when we are told to calculate the height of an object that is moving against the influence of gravity, we are going to make use of this second one. Do you understand? Please, it is very, very important that you note that. Now, I want to put down this question. This is JAM 2020 question 1. Okay, a train with an initial velocity 20 meters per second is subjected to a uniform deceleration of 2 meters per second squared. A train with an initial velocity 20 meters per second is subjected to a uniform deceleration of 2 meters per second squared. The time taken to bring the train to a complete halt is dash. They now give us an option. The first option there is A, we have 10 seconds, B, we have 20 seconds. C, we have 40 seconds. And D, for D, we are having, that is 5 seconds. 5 seconds. Okay? How do we solve this question? Let's start by listing the parameters that were given in the question. We are given that the initial velocity of the body is 20 meters per second. And don't forget, initial velocity is represented as u. U is what? 20 meters per second. You understand? And we are given that the deceleration is what? Okay, let me ask you, what is meant by deceleration? Yeah, deceleration simply means negative acceleration. You understand? And deceleration is also the same thing as what? Retardation. You understand? So now, we are also given that the deceleration is 2 meters per second squared. So, and don't forget that deceleration is also the same thing as what? Retardation. So you can just represent it as R. So R is equals to because minus 2 meters per second squared. The reason why I have minus here is because they gave me deceleration. Are you getting it? For eventually, if they gave me acceleration, I'm not going to put this minus because I have told you that deceleration is what? Negative acceleration. So this is the acceleration. This makes it the negative that we have here make it deceleration. You understand? So deceleration is what? Negative, which is minus acceleration. Okay? So let us proceed. We are also given that, okay, T, we are told to calculate the time taken. The time that the train will come to a complete halt. That is the time taken for the train to come to rest. You understand? So let me ask you another question. Don't forget that the train is in motion before. That is why we have the initial velocity as what? 20 meters per second. So from the points I gave you earlier, an object that is in motion, if an object is in motion, what will be the final velocity? That is, if a object comes to rest after undergoing motion, what will be the final velocity? The final velocity will be what? 0. You understand? So V will be what? 0. Do you understand? If an object is in motion before and the object comes to rest, the final velocity will be 0. You understand? The train is in motion before, but we are told that at so initial velocity, the train moves from this with acceleration this. What is the time taken for the train to come to rest? So the train is certainly in motion before. You understand? So V will be what? 0. We have listed out all the parameters. Which of these equations are we going to use? Are we going to use equation of uniformly acceleration motion, or are we going to use free fall? We are going to make use of uniformly acceleration motion. Why? Because we are not, the train is moving what? Horizontally. It's moving on the ground. It's not moving vertically. You understand? When we talk about free fall, that is the motion of an object vertically. Are you get what I'm saying? The motion of the vertical movement and downward movement of an object acted upon by the force of gravity. That is when we make use of free fall. But this, we are not going to make use of free fall. So now, out of this uniformly acceleration motion, out of all this equation, which one are we going to use to calculate the time taken? It is very, very easy. Since you have already listed out your parameters, you are just going to go through your equation. Which of this equation has all the parameters that I'm having here? After that, you are going to plug in. Then you solve for the value of the unknown that you are looking for, which is t. So let's look. We are going to make use of the first equation. How do I know? Because I have known the value of my v. I'm looking for my t. T is also there. I've known the value of a, which is r, which is negative acceleration. I've known the value of u, and u is also there. So I'm going to make use of the first equation of uniformly acceleration motion. Okay? So let's start. Let's plug in our... We're going to have v is equals to u plus at. Abi? So v is what? 0. That means I'm going to have 0 is equals to u U is 20. 20 plus A. A is what? Retardation. And the retardation is negative acceleration, which is what? Minus 2 meters per second squared. So I'm going to have minus 2 into bracket T. Do you understand how I got here? Okay, let's proceed. So for this, I'm going to have 0 is equals to 20 minus 2t. Do you understand? Okay, now let's move 20 to the other side of the equation. We're going to have minus 20 is equals to what? Minus 2t. So the next step is that we are going to divide both sides by what? Minus 2. To have minus 2, minus 2, minus 2. So t will be what? T is equals to 10 seconds. So the answer, the option A is correct. You understand? T is equals to 10 seconds. Now let's have another work example on this topic. Calculate the total distance covered by a train before coming to rest if its initial speed is 30 meters per second with a constant retardation of 0.1 meter per second squared. Okay, let's start by listing out the parameters that were given in the question. We are given that the initial speed, and initial speed simply means what? Initial velocity. You understand? So we are given that u is what? U is 30 meters per second. 30 meters per second. And the constant retardation, don't forget that retardation is what? Negative acceleration. So retardation, which is r, is equals to what? Minus a. That will be what? Minus 0.1 meter per second squared. I only put this so that you will know that retardation is what? Negative acceleration. That is how we have minus in this place. Now, what is the velocity of this train? The velocity is what? 0, because the train is in motion before coming to rest. And I told you that when the velocity of an object that is undergoing motion before then come to rest, the velocity will be what? 0. An object that is in motion before with an initial velocity this, when it comes to rest, the velocity will be what? 0. So it is very, very important that you note those 2 points I gave you. Okay, so v will be what? V is what? V is 0. Okay, so we are given these parameters. How do we calculate the distance? Which of these formula are we going to make use? Don't forget that anytime you want to solve any question, maybe physics, just remember, first list out your parameters. Then look at the parameters that you are given. Go back to the equation that you know. Then look at where all the given parameters fit in. Look at among this equation, where does all these parameters fit in, including the parameter that we are looking for. Don't forget, we are looking for distance, which is s. We are looking for distance. So where does these parameters fit in? We are given the initial velocity. We are given the retardation, which is also acceleration, negative acceleration. We are given the final velocity. We are told to calculate distance. Which formula are we going to make use of? We are going to make use of the second formula because we have velocity, we have initial velocity also, we have acceleration, negative acceleration, and we are told to calculate distance. So we are going to make use of the second formula. So let's go. So we are going to have v squared is equals to u squared plus 2as. Don't forget that v is what? 0. So I'm going to have 0 squared is equals to u squared. That is what? 30 squared plus 2 multiplied by minus 0.1. So multiply by minus 0.1 multiplied by distance, which is s. Are you paying attention? Okay, that will be, this one will be what? 0 squared is 0. So I'm going to have 0 is equals to 900. 30 squared is 900. Minus plus 2 multiplied by positive 2 multiplied by negative 0.1. That is negative 0.2 seconds. Okay, so the next step is that I'm going to move this 900 to the other side of this equation. So I'm going to have minus 900 is equals to minus 0.2 seconds. Do you understand? So what's next? What are we going to do next? The next step is that I'm going to divide both sides by negative 0.2. So I'm going to have this over, what happened to this marker? This over negative 0.2 over negative 0.2. So the distance here is what? Punch your calculator. 4,500 meter. Don't forget that distance is measured in meter. So the distance of the train is 4,500 meters. So